When we add or subtract radicals, we need like terms. For the radical, that means that under the radical sign, the number or letter, whatever, is the same. So, like if we had 2x plus 3x, these are like terms, and so we can take and add the 2 and the 3 to get 5x. And the x didn't change. We had 2 of these, we had 3 of these, and we're just counting them to get the 5x. So remember, when we're adding like terms, the like term doesn't change. So in the same sense, if we have the square root of 2 plus 3 times the square root of 2, we're going to add these. They're like terms because of what is under the radical. And we want to remember that in front of this one, even though we don't see it, there's a 1. So when we go to add these, we're adding the 1 and the 3 to get 4 times the square root of 2 for our answer. Now we may have to do some simplifying to be able to do this like term thing. And so let's look at some problems like that. Here we have the square root of 50 minus the square root of 32. And what we need to do here is we need to simplify. So what we've learned in our past lessons, remember, 50 is the same thing as 25 times 2, and 32 is 16 times 2. So I can take the square root of the 25 and the 16, and those square roots will come to the outside. So the square root of 25 is 5, and what's left under the radical is our 2. The square root of 16 is 4, and what's left inside is our 2. Now we have like terms that we can put together. 5 minus 4 is going to give me 1 times the square root of 2. But we don't ever put that 1. It's understood that if I just have the square root of 2, that it is being multiplied times that 1. Now you may not be able to figure out right away how to simplify what's under the radical. And so you want to remember that you can take and break these down into their prime factors. This one over here with the square root of 50 is going to be one of the easier ones, 32, because you're going to be able to think 25 times 2. But 48, 24 times 2, is not going to work. And so I'm going to take and I'm going to write this as its prime factors. So let's just start with, we know that 2 goes into 48 times 24, and 24 is 4 times 6. So that's another 2 times 2 for the 4, and a 2 times 3 for the 6. So when we're simplifying this will come out as 1, and this will come out as 1, 2. So what we're going to have here is we've got 2 times 2 coming out times the 6. So 4 times 6 is going to be 24 times, and what's left is that square root of 3. Then let's look at 2 times the square root of 32. So if I take and look at it, And 32, we've already seen it's 16 times 2. So this one's going to be a little bit easier. So that this is 1 will equal, remember this is going to come out as 4. So this comes out as 4. So now we have 4 times 2 on the outside and a 2 left on the inside. Then we're looking at the square root of 27. And see, 27 is 3 times 3 times 3. And so we can take out 2 of those will come out as 1. And so let's see what we're going to have here. So we're going to have the 24. So I'm going to kind of circle these. This was the first one. This is the second one. And then this one will be 3 on the outside and 3 on the inside. So here's my third term. Now we want to add all those. So we're going to have 24 times the square root of 3. And everything was, nope, we had a subtraction here. And then 8 times the square root of 2 plus 3 times the square root of 3. So this is what we're looking at now to finish the work. These are like terms. This one isn't. So we can put these two together. And we have simplified this as much as we possibly can. So you'll see sometimes you won't get a one-term answer. Sometimes you may have more than one term, like we did here. All right, let's throw some letters into the mix, make everybody real happy. We have the square root of 25b cubed plus the square root of 9b cubed minus the square root of 36b cubed. So you'll notice that all the b's are already the same. So more than likely we'll have like terms there, but they still have to be simplified. And this one's a little bit easier because we can take the square root of 25, the square root of 9, and the square root of 36. So what we want to concentrate here are on the b's. So remember the b's, we've got 3 of them, and 2 of them will come out as 1, and then 1 will stay inside. So on the outside we will have 5b with a b on the inside. The square root of 9 is 3, and we've got the b on the outside and the b on the inside, the square root of 36, and again we've already done, all the b's are the same. So we do have like terms. So we can add all this together. 5 plus 3 is 8, and 8 minus 6 is 2b times the square root of b. Fractions. What do we need to do to be able to add fractions? We need a common denominator. So you always, for fractions, the default here, it may not be your smallest, sometimes it is, but multiply the denominators you have. So 2 times 7 would be 14, and so that gives me my common denominator. And what we are doing is multiplying 2 times 7, and we have to do the 7 on the top two. Remember, 7 over 7 equals 1. So we're not changing the value of this term. We're only changing the appearance. It looks different, but they are equal. Over here, 7 times 2 will give us this 14. So we have to multiply 2 at the top also, keeping in mind that 2 over 2 is 1. Anything times 1 is that same number. So these appear to be different numbers, but they are actually just equivalent fractions. Then we can take and add the 63 and the 18 together. To come up with our answer. If we could simplify, we would. This is another thing that you have to keep in mind with fractions. So remember, the square root of 6 and 14 are not the same type of number. So we're not looking at the 6. We're looking at this whole number 81 in front of this 6. And so when we look at 81 and 14, 14 is 2 times 7. That is its prime factors. And 81 cannot be divided by 2 or 7. So this is a simplified answer. Let's do some practice. I'm just going to do 2 of these. Remember, to find perimeter of a quadrilateral, you just need to add the sides. And all of this is going to be in inches. Okay. All right, so you know the drill by now. Hopefully you've been watching the videos. And you know that when we do practice, I want you to go ahead and write the problems, pause, work, then hit play to check your answers. All right, so go ahead and do that. Pause it and then do the work, then hit play and look at the answers that I've given you. Okay, so here's the first step for both of these. I went ahead and took the square root of 64 And then I know I've got to get a common denominator, so I'm just going with my default, multiplying those two to get 40. The next thing I will do is create those equivalent fractions. On number 2, where I need to find perimeter, I know that I need to add. So I just went ahead and wrote down all of the lengths of the sizes of the sides so that we can add those together. Now we need to go ahead and start doing the rest of this, finishing it out. So here we have the finished answer for number 1. We are going to subtract, so 5 minus 8 is a -3. That negative can come in the front or at the top. Those are the two best choices. It can go at the bottom, but for what we're doing, we want it to be in the front or in the numerator. So here's our next step here. I am writing the 75 with factors. I didn't do the prime factors because I know, the square root of 25, I know that works. So I just broke it down to something that was simpler that I knew I could take the square root of. 12 is the same thing. I hope this is showing up. I know it's on the very edge of our video. 4 times 3. The next step is to go ahead and simplify. The square root of 25 is 5. 5 times 4 is 20. Here's the 5 on the outside. Square root of 4 is 2. 2 times the 2 that's on the outside is 4. Notice we have like terms all the way across. So now we're going to add 3 plus 20 plus 5 plus 4 to give us our final answer. Let's see. 23, 28, 32 on the outside times the square root of 3, and this is all in inches, and we're adding, so just regular old inches. Okay, that's it. Little short lesson. I took 10.4 and split it into 2 parts. That way we can focus on adding and subtracting in one section, and then 10.4b will be all about multiplying.